Okay, let's look at some of the problems from the worksheet. Let's look at 7a. The limit as x approaches infinity of 3t squared minus 7t over t minus 8. Now, one of the shortcuts for this is to remember that you're just looking for, as x gets really, really big, what's going to be dominant? Which of these terms is going to take over? And really, as x gets into bigger and bigger values, this t squared is going to take over. By the time you get up to 1,000,000, the rest of this almost doesn't matter. I mean, you've just squared 1,000,000, and so you take away some stuff and divide it. It's still getting bigger and bigger. So if the degree of the numerator is bigger than the degree of the denominator, by that I mean if the highest exponent in the numerator is bigger than the highest exponent in the denominator, your answer is going to be infinity, because this term is going to take over. So as x gets bigger and bigger and bigger in this function, the y values get bigger and bigger and bigger. Okay, so that does not exist. And also there's no horizontal asymptote. This is just going to keep getting bigger and bigger. So let's look at the next one. Letter B says the limit of 2t squared minus 6, as x approaches infinity, of 2t squared minus 6 over t to the fourth minus 8t plus 9. Now in this case, the biggest degree is in the denominator. So the term that's going to take over is going to be this term right here. As we get bigger and bigger and bigger, this term is going to eclipse everything else. Because you think about it, if you took 1,000,000 to the fourth, subtracting 8,000,000 is hardly going to matter. If you have 1,000,000 to the fourth here and 1,000,000 squared here, this 1,000,000 to the fourth is still incredibly bigger. So what happens is you end up with, as x approaches infinity, as x gets really big, you have a number on the top and a really huge number on the bottom, right, because of that t to the fourth. So a number over a huge number is getting closer and closer to 0. So that means that this approaches 0. And the shortcut to this is, if the biggest degree is in the denominator, then you're going to be approaching 0 as x goes to infinity, because you're going to end up with some number over a much bigger number, which is always going to lead to 0. Okay, so let's do letter C. Letter C is the limit as x approaches negative infinity of t over t to the sixth minus 4t squared. So our biggest exponent is right here. It's the t to the sixth. So again, we're going to get a number over a really huge number. So this is going to lead us to 0. And what both of these mean, by the way, is that there would be a horizontal asymptote at 0. Because in this one, as x gets really big, the graph is going towards 0. In this one, as x gets really, really small, the function is heading towards 0. So let's look at letter D. The limit as x approaches negative infinity of 3 equals, now this one you may have to think for a minute. You may have to remember that the limit of a constant is a constant, or you may just want to sketch the graph. Remember that this is your function. So if your function was f of x equals 3, what would that look like? Also remember that this is your y value. So if your y value was 3, what would that look like? Well, it would look like a straight line. So as x goes towards negative infinity, what is y doing? It's always 3. Okay, let's look at letter E. Now we get into something that's a little bit interesting. E says the limit as x approaches positive negative infinity, and let's stop there. I don't like it when they write it together because it's two different things, right? We're looking at x as it gets really huge, that's positive infinity, of course, and then x as it gets really small. So let's actually write this twice. So let's do two problems here. Let's do the limit as x approaches infinity first of 5t cubed minus 7t squared plus 9 over t squared minus 8t cubed minus 8,999. Okay, so let's do the positive infinity first. Well, the first thing we see is that the highest exponent in the numerator and the denominator equal each other. So if you remember from your rules, that means that our solution, our limit, therefore, is going to be a ratio of the numerator to the denominator. So in this case, as it goes towards positive infinity, we'd have a 5 and a negative 8, but this t cubed, oh, that's going to be positive, right? So it'll keep it 5. This t cubed is going to be positive, so it'll keep that negative 8. So no problem, we get 5 over negative 8, negative 5/8. So then the limit as x approaches negative infinity of this same function, I'll tell you what, I'm just going to keep the important numbers. 5t cubed over negative 8t cubed. Negative infinity. So actually, this is going to be a negative number, isn't it? It's going to be negative 5. Right? Because if I plug in a really big value for a really small value for t cubed, such as negative 100 for x, that would mean that I would get a negative number here. And then, if I plug in a negative number in the denominator, I'm going to get a negative number because I'm cubing it times negative 8. It's actually going to be a positive 8. So interestingly, our answers are the same, negative 5/8. Okay, so the point of that is just watch your negatives when you're going towards negative infinity. Make sure, especially if it's an odd function, that you check the signs. And for f, it is the limit as x approaches negative infinity of 1 minus s to the 5th over s to the 4th plus s minus 1. So the biggest exponent is in the numerator. So this is going to be the dominant term. And we're going to negative infinity. So this number is going to be negative. But we're subtracting it. So we're subtracting a big negative. That is going to get us a positive. So as s to the 5th goes towards negative infinity, negative s to the 5th goes towards negative infinity, s to the 5th gives us very big negative values. But then we stick a negative in front of a negative, and it becomes a positive. Okay, I will continue on the next video, starting with letter G.